Hello everyone, welcome to DAOCrossing DevLog. Um, like I said in the last video, I mentioned that I built a very cool function where you can take a screenshot with your avatar right here, and then you can upload your customized avatar to IPFS, and then after that you will generate a JSON file containing the IPFS hash of that image, and then eventually you will be able to mint the uh, avatar as an NFT. So let's just do like a quick demo here. So if I go to shop right here, and then we'll just do some random clothing. Maybe I'll do this one instead. And then if you go to this button right here, you can take a screenshot of your avatar. And let's take a look at the console right here to see what happened in the behind the scene. So after you take a screenshot, you can upload it to IPFS. You just click this button right here. As you can see, it's running, and then it will return a CID hash. And then after that, you will generate the JSON file and then also upload that JSON file to IPFS. And finally, you will be minting this avatar as NFT, and just copy this hash, and then you can go to the RinkyB network, and then you just gonna paste that hash, transaction hash, and see if it's already success. And it seems like it's already being transacted. So we can then just go to our wallet, and then let's see. So as you can see, it already came through right here. It probably took a while for the image actually showing up. So let's just gonna wait that. But in the meantime, I will show you how do I build this free mint within the Unity game one by one. And then of course in the end you can merge all those functionalities into just one button, and then just click on mint, and then make the user, like right now I'm just using my own private key, so I'm just pay for the gas fee for whatever mint they do. But if you change the contract a little bit, you can also just ask the user to pay for the gas fee. So that's pretty much it for the demo. So let's start with the first button right here, where you can take a screenshot and save the image in either your local computer or the Unity cloud. So let's take a look at the function. So for that button, I use this function where I use the coroutine. There are a lot of YouTube videos about how to do a coroutine function, and then also how to take a screenshot in Unity. So it's not gonna be my major focus right here. So I'm just gonna mention a couple of the tricks I put in here. So just give you a better idea. So for this couple lines, I basically just pick the center point for my avatar, and then I did a ratio thing. So I know people are using different screens, and they're gonna be different widths or heights. So it's not gonna work if you use a fixed width or height that you inputted from in your game object. So what I did is I input a ratio. So right here I have a float where you can identify the ratio to the screen and determine the width and height of the dimension of the image that you're gonna take. So since we're gonna take a square, so I just make that I make the width equal to the height right here, and then the rest is just how you take a screenshot. There are so many tutorials on that, but you can just copy this part for convenience. And then it will either, if you are using WebGL, you want to use just this function, so persistent data path instead of the data path, because if you call application.data path, it will save it to your local computer, and it doesn't work on WebGL if you're playing your Unity game on browser, and then it will automatically save to the Unity cloud. I think it's they use IndexedDB. Okay, let's move on to this line right here. So for the image, if you if you want to display like I did right here, you can just make an image object, and then you can set the image the sprite to whatever you just screenshot it, and then the screenshot will be showing up here. So that's pretty much it for the screenshot part. So you after this button, you will have your image either stored in your computer, and you're gonna upload that from your computer, or it will be stored in the WebGL cloud, the Unity cloud, and then they will upload from there instead. So let's move on to the next button right here, which we will be uploading the image that we stored in either the computer or the cloud to IPFS. So as you know, we have Ninata or NFT.Storage as the gateway for those IPFS file. In this case, we will be using NFT.Storage, and the reason being that they have this really awesome Unity NFT.Storage C# file that we can just simply use the function that they created to upload the image to IPFS. So there is a very awesome tutorial I found online, and for some reason they only have 8 likes, including me, where it went through how you sign up for NFT.Storage, how you get the API keys, and how you use the function call to upload the image to IPFS. And then it will be reflected on the NFT.Storage account that you have. So with that being said, I will not going to go through everything they mentioned in this video, but I do want to mention that they also made a very awesome pull request. So if you are just going to use the default one, the default C#, the NFT.Storage created, you will not be able to upload images. So you will only be able to upload texts, I think, to NFT.Storage. So what this team did is that they actually, let me go back to it. They made a pull request, and then they made changes to the pull request in the pull request where they add this function such that if you're calling this function right here, and you will be able to upload images or any types of files to NFT.Storage without restriction. So that's very important. I will also put this link in the description, and you can just copy and paste and change whatever they add or subtract from the original C# script, and then just use that in Unity project. But also, in addition to what they did, I also made some changes to their pull request. So let's take a look at the script I modified in addition to their pull requests. So the only line I changed is right here. I commented out this part where it calls a default request headers and add the authorization to the header. The reasons being that when they made that pull request, they add this new method right here where you also call exactly the same method where you add the authorization to a header. And I understand what they made is that they in this if statement they trying to remove any duplicated authorization headers, but for some reason that didn't work, and then Unity is complaining about it. So you cannot access more than one authorization for some reason. So I just comment that part out, and then just leave everything as it is right here. So now you will be all set for use this script in your Unity project. So if you go back to Unity, and I created like a manager, like a screenshot a manager here, and I put the screenshot handler that I made before, and then also the NFT.Storage client that we modified right here. And then in here, if you go to the screenshot handler, and if you go to this method, like a super simple method I used for the second button, upload into NFT.Storage, you can see that I'm using this object, the NFC. And if you look up, it's actually the NFT.Storage, the client NFC. So to use that, you will need to drag that NFT.Storage to the manager, and then you drag this right here. And that's how you use this script in another script. And within that script, you also need to get your API token for your NFT.Storage, and then you will be all set for uploading your image to your NFT.Storage. Because all you need to do is just call in that simple method in the pull request where it says upload data from string Unity web requests. So that's it for the second button right here. So someone might be curious about this field right here. So it doesn't exist in the original C# file or even in the pull request. So that's something I add in the script because I want to use this new game object to store the CID being returned from the call. Because we want to use that CID which pointing to the image and then generate a JSON file and then upload that into IPFS again in the next step for generating the JSON file and upload it to IPFS. So we need that hash and store it somewhere. So that's why I created this game object. And if you go to the script I created, I copied. I also made some modifications. So right here in the post request. So post request is the new method being added to the pull request. And if you look at this part, they used to only have this line right here. So I add this line to incorporate the response being returned. And then I created a new data type, the JSON type called NFT.Storage custom upload response. And the only reason is that for some reason the response being returned doesn't have like an arrow field, whereas the original one they have like an arrow field. So if you go back, if you go to the regular one, the original response they have these three field, but for the pull request for some reason they only return the first two but not the third one. So all I did is just make a new one and then just comment out this part, because only that you can correctly mapping the text response being returned from NFT.Storage to a correct JSON file. So for these two lines, I just used the game objects and the store the CID. So if you want to get the CID, you just call the parse response.value.cid and then you restore that into the text field of the game object. So that's pretty much it for how you upload the NFT to how you upload the image, the avatar to IPFS, and we will move on to the next one, which is generate a JSON file. Actually, for the time being, I will just record the first two buttons and then I will divide this tutorial into two parts. So I will see you in the next tutorial.